Hi everybody, I'm still Ms. Lee. So in this video, we're going to talk about a specific type of series. So a specific type of like when you're adding stuff up. And it's called a geometric series. And so a geometric series comes in the form of the series from k equals 1 to n of a times r to the k minus 1 power. So this is what we call a geometric series. And so each of these sort of letters kind of represent something. So for example, the n is the number of terms. R is going to be your base. Obviously, this looks like an exponential function, so this is the base of the function. A is going to be your first term. So if you think about this, when you plug 1 into this function, so k equals 1 into this, you get r to the 1 minus 1 power, which is r to the 0 power. And r to the 0 power is just going to be 1, and 1 times a is just a. So a is going to be your first term. R is your base or common ratio. So R generally is for ratio. So R for common ratio. And K, of course, is your index of summation. And so N will be your number of terms. N is your number of terms. And if you think about that, that makes sense because we're starting at 1, we count up to n. So if you count up to n, there's going to be n of them, so n terms. Okay, so we're going to go ahead and do an example, and then we're going to come back up. So leave space over here because we're going to write something there later. So let's go ahead and do an example of this. Okay, so this is the expression we're going to find the sum of. But if you're looking at it, this goes up to 26. I'm pretty sure none of you want to add all the numbers up to 26. So what I'm going to go ahead and do is kind of show you a trick as to how to find this sum in a shorter manner. Okay. So if you just think about this, when we plug in, say, k equals 1, what we have is 3 times 5 to the, and then 1 minus 1 power. And then when we plug in 2, so we're going in order. I'm not going to do all of the terms. I'm just going to do some of them so I can show you what's going on. What I get here is going to be 3 times 5 to the power of 2 minus 1 plus 3 times 5 to the power of 3 minus 1 plus, and then I'm going to use a dot, 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 so an ellipses, plus, and then I'm going to just do the last two terms. So the last two terms are going to be 3 times 5 to the power of 25 minus 1 plus, and then 3 times 5 to the power of 26 minus 1. Okay, so this is the sum that we want to add up. And so I'm going to call this S. And just as like a reference, S is going to be what we want to find at the end of all of this. So let's go ahead and simplify this just a little bit. So 1 minus 1. So S equals 3 times 5 to the power of 1 minus 1. That's 5 to the 0 plus 3 times 5 to the 1 plus 3 times 5 to the 2 plus, and then so on and so forth, plus 3 times 5 to the 24th plus, and then 3 times 5 to the 25th. Okay, so what we're going to do is we're going to multiply this entire expression by the common ratio, which is 5. So we're going to multiply each and every term, so you have to distribute the 5 to each and every term. So 5s equals, so S, remember, is the sum that we want to find. So 5s equals, and then we're multiplying each of these by 1, 5, which means each of these powers are going to increase by 1, because if you do 5 times 5, that's 5 squared. If you do 5 squared times 5, that's 5 cubed. So 5 times all of these are going to be 3 times 5 to the 1, plus 3 times 5 to the 2, plus 3 times 5 to the third, plus 3 times 5, so on and so forth, and then 3 times 5 to the 25th, plus 3 times 5 to the 26th. Okay, so just a reminder, we're solving for S. Okay, so don't forget that. So what we're going to do right now is we're going to do this expression minus this expression. So what I'm saying is we're doing S minus 5S. And so if you're looking at these two expressions, we have a lot of terms in common. And so when you subtract, a lot of these will go away. For example, 3 times 5 to the 1, subtracted, those two will go away. So when you subtract this minus this, these two will subtract to 0. And then 3 times 5 squared, those will subtract to 0. And then everything in between will also subtract to 0. So these will all match up since they all increase in the same way. All of these will subtract to 0. And then the last terms that subtract to 0 are going to be the 3 times 5 to the 25th. Those two will subtract to 0. So ultimately, all the middle terms go away. So the reason we are doing S minus 5S is because now we're going to be left with only the end terms. So we don't need to worry about anything that happened in between because they're all going to add up to 0. So then we're going to have 3 times 5 to the 0, that's that one, minus 3 times 5 to the 26. And so this is a much easier expression to deal with. And so over here on this side, what we're going to do is we're going to factor out the S. And I'm going to leave this unsimplified so that I can generalize later. So S times 1 minus 5 equals 3 times 5 to the 0 minus 3 times 5 to the 26. Okay, so I'm going to divide by the 1 minus 5. And so we have S equals 3 times 5 to the 0 minus 3 times 5 to the 26 all over 1 minus 5. And this is your answer. You can leave it like this. Some of these expressions are going to be a little bit too big to put into your calculator, but you can also put it into your calculator and see what it gives you. So 3 times, and then 5 to the 0 is 1, minus 3 times 5 to the 26th power, and then divided by -4, what you'll see is that there's like a little e sign there. And so what that means is times 10 to the power of, and then 18. So this number is a little bit too large. So when you're writing your answers for these, you can leave your expression like this. You can leave your expression like this. This can be simplified a little bit more, of course, but I'm leaving it like this so I can show you something really cool. So it happens that any geometric series, so any series that looks like this and has this format where it's basically an exponential function, follows this sort of pattern. And so what I'm going to go ahead and generalize is take the pieces of this that are the first term, so the A, the R, and create a basic formula. First of all, what I want us to do is I want to factor out the 3 and simplify the 5 to the 0. So we have S equals 3 times, and then 5 to the 0 is 1, so 1 minus 5 to the 26th power over over 1 minus 5. Okay, so I have now generalized this, and what I want you to notice is from the original problem, the 3 is basically the A, or the first term. So 3 is basically A. So this is A. The 5, of course, is the base or the common ratio. So if you're looking at the original problem, the 5 is the base or the common ratio. So this is R. So each of these are R. And then the 26, of course, is the number of terms. This is the number of terms. So this is going to be N. And so if I rewrite that using these generalized variables, the general formula for adding a geometric series is going to be S equals A times, in parentheses, 1 minus R to the n power, all over 1 minus R. And so for those of you who've been in my class before, anything that's important goes in a pink cloud. This goes in a pink cloud. So this is the sum of a finite geometric series, and we're going to write this over at the top too. So we're going to write it here. So sum of finite geometric series, and then we'll also write it over here. So go back to the top of the notes from this video, and we're going to say this equals A times 1 minus R to the n over 1 minus R. Okay, so instead of going through this process, you can actually just plug each of these numbers into this formula. So go ahead and give it a try. Happy day.